guys, welcome to Mobilemaths with Gamchrai. Today we want to look at geometrical transformations. So for starters, we are going to introduce each and every transformation that we know. So I'll start with transformation. What is a transformation? A transformation is basically the name that is given to a change in position or dimension or both of a shape. So when we talk of position, let's say we've got a triangle on our Cartesian and our triangle was there. Now it has moved to this position. That is the change. This is transformation. There is a change that has happened. Okay. Then when you talk of dimensions, we talk of the shape size. Maybe it has changed to this. Okay. So that's the change in dimension, or it can change. In this case, when I have drawn this one, the second triangle that I have, so this was the first, the second, and the third. So the third triangle, as you can see, it has changed the dimensions and it has also changed the position. Okay, so that's the both that we have. That's what we call a transformation. Okay, now the second thing that we can look at is an image. Okay, when we talk of an image, I'll have a mirror line. Let me have a mirror line here. So this is my mirror line. I'm saying line because in mathematics we talk of lines. But when I talk of a mirror, I talk of the mirror that you know. When you go and see yourself, okay, what happens when you see yourself? That's where we say an image is the result figure after transformation. Okay, so when I see myself here, this is me here. Okay, this is me here. Okay, and I look at the mirror, then I can see myself inside the mirror. Okay, I can see myself inside the mirror like that. Then what I see inside the mirror, what I see inside the mirror, this is the image. Okay, and I've taken liberty to show you. If you can take note of the legs there, they are showing us when you have a mirror line, this is what happens. That's why when you see in the mirror, you see yourself seeing yourself. That's you will talk more when we'll be doing examples. Let's have another. Let's look at congruence. When we talk of congruence, this is the transformation in which the dimensions of the original shape are the same as of the image. So I can have a Cartesian plane here. So when I have, let me have a box this time. I can have a box this like this. So here, let me have as 1 is 2, and I can have 1 is 2 there. So here I'm taking this y-axis as my mirror. So this box there is congruent to that box because they have got the same shape, they have got the same image, they have the same image, they also have the same dimensions. Okay, that's what we call congruent. Okay, now we have some transformation. When we look at congruent that we have, we've got 3 special transformation that we have. These are translation, we have got also reflection, and we have rotation. Okay, so I'll talk about each one of them little by little. So I'll start with translation. When we look at translation, we are looking at the movement. We are looking at the movement in a straight line. Without turning. Okay, so if I have my Cartesian like this and I have my triangle, I like using triangle, I can transform this triangle, I can translate, this triangle to that position there. So this is triangle number 1. So it can go to that position, and this I have my triangle number 2. So it has moved in a straight line it has not turned. Okay, that's translation. Let's look at reflection. What we call reflection. Reflection is the same like when you look into the mirror. I will not explain much. I'll just elaborate what reflection is. When you look into the mirror, what you see in the mirror is the image. So that's basically reflection. So the image and reflection go hand in hand. Okay, let me draw a Cartesian for reflection. Okay, so I just want to show you something. Let me have this triangle, right angled triangle here. So when I reflect this, it's like when I reflect the distance here and the distance here is going to be the same across the mirror. This is the mirror line. This is the mirror line. This is the mirror line. My y-axis is the mirror line. So it's going to have the same distance. Then the sides that are close to the mirror are going to be close on the other side. The sides that are far, this one is also going to be far on the other side. Though this one is not congruent enough, but please guys, it's the same thing. It's just drawing here. Okay, I think it has come out. So this is what we have when we talk of reflection. Now let's look at rotation. Okay, let's look at rotation. When you look at rotation, we are looking at when the shape is turning. Let's have rotation. We have a shape turning. So I'll have my shape here. Let me have it like this. Okay, like that. Okay. So when we talk of rotation, we talk of 90, 180, 270 degrees. So this is the 90, 180, 270 degrees that I talk about. Then if it rotates 360, then it's now reflection, isn't it? So when we rotate this triangle A to triangle B, I can have something like this. So it's like when you rotate, you take rotation at a point. So I can take this as my point. So I'll have my rotation as this. So my triangle is going to be like this. It's going to be somewhere here, like this. It is rotated. And if you are to take your compass, you find out it will be like, it will form something like this. It will form, these lines will be close to each other. These lines, these edges, sorry, will be like close to each other. Am I right here? No, this is not right. This right angle corner will come to this right angle corner. Then the second one, when you use your compass, comes to that. I'll show you when we'll be doing examples properly. Okay, so that's rotation there. Let's look at other transformation that we have. We have got 6 type of transformation. We've talked of translation, reflection, rotation. We also have what we call enlargement, stretch, and shear. Okay, now when we look at enlargement, we are looking at enlarging. We are increasing the size of something. It's like when a shape is being magnified, or is being made larger, or is being made smaller. Let's have a Cartesian plane there. So I can have let me have a triangle. Okay, it's right angled. So I can enlarge this at a point and have something like this, and have my triangle like this. This was triangle number 1, and this is now 2. So I've enlarged it like that. Or else I can enlarge it to become smaller at point number 3 there, triangle number 3. So that's why I said enlargement is when we magnify, or we make something larger, or we make it smaller. Okay, then when you talk of stretch, we are stretching. Think of we are stretching. You can stretch. Let's have an example to clearly elaborate this. Okay, if I have my Cartesian like this, x and y, and I have my box like this, so I can stretch it like this. I can stretch in this direction, in the x direction. I can also stretch it in the y direction and have something like this. I've stretched it. we call it stretching. Okay, it's not enlargement, it's stretching, though it has become bigger. Okay, think of another example that I can think of is when you take your rubber band and you stretch it. It's like it's becoming bigger and bigger and bigger, but that's what happens. Now the last one is shear. Okay, for shear, I can talk of a pile of books. Let's have a pile of books. This is a pile of books. These are books, these are books, these are books. So when I talk of shear, I can push here. I'm pushing here at the top. This is the table. I can push here. When I push, this edge will be going this side, such that when I push, it becomes something like this. I'll form something like this. I can have the same position at the base, but it's going this direction. My books are shifting on the top. That's what we call shear. Okay. There's a portion where we say it will remain stationary. You see. So these are the transformation that I've talked about. I've talked about enlargement, I've talked about stretch, I've talked about shear. There are some factors that will be introduced when you look in geometrical transformation. We have got enlargement factor, we have got stretch factor, we've got shear factor. Okay, and these will be very helpful. Okay, let's have another example. Okay, here we have got translation. Okay, we are now going into detail in translation. So here I can have an example, and we say translation is the movement in a straight line without turning, and we have what you call a translational vector that is being used to move a point to another point or to its image. So the translational vector is in the form of xy. Okay, meaning to say we move in x direction certain units, and we move in y direction certain units. Okay, now let me have an example of we want to try a point. Let's say I've got a point 1 2 by a translational vector. Let's say we've got 4 2 there. Okay, instead of me to go into my my graph and drawing these points, I can simply find the new position. I can simply find the new position using, I can use this translational vector. Let me use it where I have 1 2 as my position. Then because of this translational vector, I can say plus 4 2. So for me to get the new position, it becomes the addition of these two. 1 plus 1, 1 plus 1 plus 4, sorry, I will get 5. Then 2 plus 2, I'll get 4. So my new position is 5 4. Okay, that's what we do when we look at translation. Let's have another example. So here I've got this example, and I want to use, let me write my translational vector. My translational vector, I'll have 6 minus 5 there. Okay, I want to move triangle MNO to triangle MNO. Then when it's an image, we can say image, image, image. Okay, these dashes there are simply referring to image there. Okay, like that. So I want to move triangle MNO to MNO image there. So our translational vector is 6 in the x and minus 5 in the y. So what we do is we are going to move, let me take point N. We're going to move 6 points in x direction. I'll move 1 2 3 4 5 6. Then I move how many in the y direction? 1 2 3 4 5 6. In the y direction, I'm moving minus 6 minus 5. 1 2 3 4 5. So my point N dash is coming here. So this is my point. I can mark it. Then now I can go on to the next point. I have O there. I can move from point O 6 units. 1 2, 3, 4, 5, 6. Then I go down 1, 2, 3, 4, 5. Okay, so my point O dash is now there. Okay, let's do the last one. The last one is point M. I can move 6 in the X. 1, 2, 3, 4, 5, 6. Then 5. 1, 2, 3, 4, 5. So my M dash is here. Okay, now I can draw my triangle and have it as this. This is the image that I have. Okay, so that's how we do this. Otherwise, let's meet in transformation 2. Bye bye.